All right. Just finished talking about ATP. You guys ready for fermentation now?
Wait,
Are
what? Wait, what?
Are you ready to look at fermentation now?
Oh, actually, I kind of need to go to bed. I haven't been studying a whole bunch, but I just need to go sleep, I think.
Okay.
Right. Well, good luck on the test.
Yeah.
Good luck to you guys. This is the only kind of fermentation I need to know about.
Boy!
Whoa! Whoa! Tyler?
Who's Tyler? I'm Arthur Hardin, 1929 Nobel Laureate in chemistry for my work in phosphates and fermentation.
Oh, that's cool. I've been studying about you in my chemistry class.
Of course you have. I'm a genius, but you don't seem to be. So your exam tomorrow requires you to have a fundamental understanding of fermentation, so I'm here to help you.
Well, I mean, that's nice that you would offer that, but I think I got a pretty good grasp on it. There's like 3 kinds of fermentation, and then there's something in there about a phosphate, I think.
You don't seem to understand the whole fundamental process of all of this, you thick buffoon. Here, let me show you.
Fermentation begins with the single-celled fungus of yeast, seen here. It produces alcohol as a result of digesting sugars and creating its own energy. This process is what we humans use to make alcoholic drinks like beer and wine. A series of complicated reactions inside the yeast cell occur during fermentation, including the change from pyruvate to alcohol, which will be important later. This investigation began by injecting animals with a yeast serum to study enzymes. After boiling away the reaction-driving enzymes in the yeast juice, the rate of fermentation increased, even though the enzymes causing the chemical reactions were destroyed by the heat. So, some time was spent at the drawing board until, bam, phosphates were determined to play a role in the reactions. There were 3 types of fermentation reactions. Type 1 starts with a bang and fizzles out, like in this boring graph. In this equation, sugar converts to carbon dioxide and alcohol. Phosphates form sugar esters until they run out and the accumulation of sugar esters is too high. Then the reaction crawls to type 2. Type 2 occurs when sugar is added to active yeast. The rate of fermentation is dictated by the phosphate supply. This supply comes from phosphoric esters being broken down by phosphatase enzymes. The phosphates are then turned back into a sugar ester before they split apart via hydrolysis. If more phosphates are added, then the reaction becomes a type 1. Type 3 reactions start strong and stay strong. This reaction has stimulated phosphatase, which means that hydrolyzed esters create more phosphates. The fermentation rate stays high because there is no accumulation of sugar esters. Living yeast usually has a higher rate of fermentation than the yeast juice. However, with phosphates, juice is much quicker.
Okay, so that explains what ATP is.
Wait, what's ATP?
Never mind, that's after your time. What's that noise?
Von Euler.
Arthur Hardin. You always forget to talk about me when you talk about our work in fermentation.
Fermentation is mostly the action of phosphates. I can't see how enzymes would be that important.
Are you kidding me? Enzymes are what drive the reactions. Your fermentation would be nothing without these.
Well, I mean, how important can it be, though?
We'll show you.
Von Euler focused around the driver of fermentation reactions, the enzymes and their helpers, cozymase, aka NADH. This coenzyme survived the heat, which makes fermentation possible. Cozymase breaks down phosphoric esters by speeding up reactions. Then it transfers electrons to pyruvate, producing alcohol. In conclusion, fermentation can be seen on the base level of muscles in animals, in several plants, and microorganisms, and it can help form bones.
Oh no, I'm gonna be late for my test.